want to talk to you about today is a product called Pysheets, but a little bit of history about myself. I've been in technology half my life and in finance the other half. So I mean like coding in finance. I'm a software engineer, but in different organizations. But I've always cared about communication between engineers and other people and engineers between engineers. I actually wrote a book about this as well. So that's the other half of my life is talking about communication. And I bought a couple extra ones, so if you want a copy, meet me afterwards and then find me and explain to me why you think communication is important and you get a free book. So in my career, I've always seen business people and IT people having a problem communicating with each other. So IT people are typically, let's generalize here, nerds, computer scientists. We like to solve problems. I'm one of them. Events like this cost me energy. I don't want to talk to people. And business people, they want to tell the IT people what to do, but they can't explain in terms of technical things. So we're always fighting with that. It has been like that since I started. I started with mainframe programming. Actually, my first coding was on cards with pens, and that we sent to somewhere else in the Netherlands, and it took a week for you getting your answer back. And it said like syntax error on card 17. So the round trip there, well, let's now talk about how short the round trip is now. But there are silos, and we want to break them down. So what I will do is talk about Pysheets. You see a QR code here, so take a picture of it, go to Pysheets app, follow the link and try it out. Go to the GitHub repo, it's an open source project. And I'd like to get more stars than 22. There's 22 right now. We need to get to 1,000. Come on, guys. So go to the QR code and please star it. So I want to talk about the problem. Why Pysheets and what problem am I solving? And it comes down to actually looking at the underlying tech stack that we have today, which is Python, Jupyter Notebooks, and dashboards for basically explaining the data science findings that we find as coders and engineers and big data analysts and give to the business. But Python programmers are from Mars, and the business are from Venus. That's that book about relationships between men and women. It's the same for ours. So I want to bring them in a closer orbit. So notebooks, what's wrong with notebooks? Jupyter Notebooks, they are intrinsically linear. I call them one-dimensional. So they're linear. You start at the top, you write something, and you go down. And this is fine for science papers that explain a certain theory and that go down the steps. And each step you can validate and run the code. So notebooks are extremely popular in that domain. There are like 7 million notebooks on GitHub alone. So there's nothing wrong with that. But the way that most people think about things is graphs. So I think in graphs. Like my PhD topic was an object-oriented language, and we had objects working as agents, and they're sending messages to each other. So very quickly, if you want to explain how things work, you start drawing circles and arrows, and you draw a graph. And this is still today. Like this morning, we had a perfect presentation by Julia on LangChain, and she focused on visualizing that graph so that we can actually see what is happening, and including the cycles in the system. So for me, everything is a graph. I said like I was coming from the Netherlands. The Netherlands is known for tulips and stroopwafels. I also brought stroopwafels, so if you want a stroopwafel, then. But we're also known for graphs. And everybody who has heard of the Dijkstra shortest path algorithm, that was written by a Dutch professor, Dijkstra. So we have a history with graphs in the Netherlands, and I want to fix that. So what is wrong with Python and Excel? That's the other observation that I had. Is last year Python and Excel came out from Microsoft. It's now in production. But if you want to use it, you have to, they charge you $24 per month extra on top of Microsoft 365. So that's one problem. But also Python and Excel means that you can run Python inside the Excel spreadsheet in a cell. Instead of having traditional Python or Excel expressions, you can use Python code. But it should really be called Python outside of Excel because it runs on Azure in the cloud. It doesn't run locally. So the theme of this conference here is local first or local, run everything local. So I wanted to fix all of this. So Python in Excel, I think that's for losers. What I want to do is Excel in Python. So I wrote it. I wanted to prove that it's possible to write a spreadsheet, run it in the browser, and run all the code in the browser as well, store everything in the browser, and see how far I can get. So first, a quick demo. And my machine should still be up and running. So this is, when you go to Pysheets.app, if you follow the QR code that I had in one of the slides, you end up here. So this is an explanation of what the project is about. It explains the problem we're solving. There's a link to the pitch deck. So this is for all the investors in the room here. Go there, click on it, get excited, call me, give me $3 million. The lean sheet is there, but also the slides for this presentation is there. And there's a try button. So the try button will actually run it. So let's click that. And this opens up Pysheets itself. So this is what's running right now. So this is not so impressive, this UI. There's a toolbar and buttons, but this is all run in Python. So Python code creates this UI when it runs in the browser. And if I create a new sheet, it actually renders a spreadsheet in the browser. So what happens here is we have a couple VMs starting up. So let me get my mouse, which is actually in my little pocket. Here it's a little bit easier. So what I have here is 2 VMs running. So one is the MicroPython VM. So Python is compiled into WebAssembly, and it runs inside the WebAssembly stack here inside the browser. But I have 2 VMs. So one is MicroPython to do UI startup, and you can see it's like 80 milliseconds. There are some words there. It's clipped off. So the green line says running MicroPython. So this is for the UI. And it's about 80 milliseconds. So we talked a lot about like small numbers, right? Try to run things fast. But to run pandas, you need a bigger Python VM, and that's the official CPython VM. So I have 2 VMs. So one is the UI, and the other one is in a worker, and it can do all the work, like doing things. So what can you do here? Well, it's a spreadsheet, so you can enter words in here, but let me copy-paste something from an existing spreadsheet. So this is Google Sheets. So I selected an area, and I would do copy, and then go back to my untitled sheet here, and here I do Control-V, and this will paste from Google Sheets into Pysheets. And now I have a little table here, country, import, export, and these are fake data, of course. But what I can do next is select an empty cell, and you can see there's this extra button here. So this is what I call LLM buttons or magic buttons, or that's why the star is there. So you can click on this, and what it will do is create a prompt, sends it to ChatGPT or OpenAI, and it generates the Python code to implement my prompt. So this is the code generation from that. And what it did is it created a pandas data frame. So this whole effort is actually a dedication to Wes McKinley. He talked this morning as the first speaker about, or the second speaker about him designing pandas data frames like 16 years ago or so as a young programmer. So this is like, pandas data frames are the standard for basically data science today. So what you get now is a pandas data frame. So I turn this text into a data frame. But you see there's another button that appeared, C7. And I click on that. And it says, like, visualize a data frame. Oh, this is actually creating a loop. Hey, that shouldn't be doing that. So let's start over. Believe me, I practiced this a lot, and you still make errors. So this is why you never do demos, but I'm like sort of like a rebel, and I still do demos. I don't listen to people giving me advice. So I create a data frame. And then in a different cell, I say visualize this. So this is the prompt again. This goes to OpenAI, and it comes back with an answer. The screen real estate is always a challenge. But this code, I actually added this AI because I didn't know what Matplotlib API was about. So I had to learn myself, and I was starting like going to Stack Overflow, and I said, hey, this is silly. We have AIs these days. So all this code here is generated automatically. And this is a bar graph right now, so let's make it a little bit smaller. So for this demo, I can move it around. Let's make another one. So I use the same prompt, Then will give me another bar graph. But if I like pie charts, so here it says make a figure. So I do a pie chart. So I'll just change the prompt and regenerate. It will generate new code. And now I have basically 2 visualizations for the same data. So as you can see, there's a dependency graph. Like I talked about this earlier, we think about things as graphs. So I thought I also have to show you what the graph looks like. So when I hover over the graph of this chart, you will see it's a figure, and the figure depends on the data frame, and the data frame comes out of this data. So if I now change this and say 50, this dependency graph gets executed and all the data updates. So that's about it. It's interesting here. You can even do things like XKCD, which is very popular. Way of visualizing your code. Now it's an XKCD pie chart. So you see how quickly that is without knowing too much of the APIs. You can do this data science. And this is an exploration tool. We want to figure out what does my data look like. Everything runs locally, and that's the whole point of this. So what does it mean to run locally? I mentioned that. I got 2 VMs, one a MicroPython VM, which is for embedded devices, starts up in 100 milliseconds, so it builds the UI very quickly. The other one is a full-fledged Python VM that can run pandas and matplotlib, and it runs in a worker. And they talk to each other, they send messages, but all locally. They can also talk to the spreadsheet. So if you want, you can actually escape your sandbox and change everything that's in the UI. And that is impossible in Excel. I demoed this to Guido van Rossum, the inventor of Python. And he said he tried to lobby, he works at Microsoft now, and he tried to lobby for the Excel team to open up from the cells so you could actually contribute to the menu bar, for instance. But they wouldn't do that. So if you want to do that, use Pysheets. So running locally is important. Everything is in the browser. So storing is also important. Where do you store your data? There's a lot of emphasis today on different database solutions. And so what I did is I wanted to make it easy. When I started with Pysheets, 10 months ago, I thought okay, I'll just do App Engine. I know how App Engine works, and I use Firebase. And then I was showing this to a potential customer, and they said, but there's no way we can use Google App Engine. It has to run locally, on-prem, and it has to use our database. Which database? And they said, Mongo. Okay, so I'll spin off a source graph Cody, and I refactored my code in an hour, and it ran on Mongo. And then they said, well, maybe MySQL. Okay, go back to the AI and regenerate the code. And this is we went through the iterations in a day, and then I heard about this conference, and I thought I should really try to make it really just local. So the final version that you just saw the demo of, if you go to the URL and you try it out, you will store your sheets in IndexedDB. So there's no external storage anymore. Everything is local. So I'm trying to be sort of I'm not going to say the word, but retentive. Something retentive? Yeah. I wanted to make it really, really, really local. So that's what I tried. So the next step, so we have run locally, store locally, so prompt locally. So what I did is talk to this customer, and they say, we can't use OpenAI, of course, right? I work at a bank. This is we can't send our data there or our code, whatever. There's compliance reasons why you cannot do that. There's also cost involved, of course. So then I thought, wait, I'll just install Olama, and I do it locally. I was very hopeful. I bought a new PC, which is a Copilot Plus PC, which can run AIs locally on it. So I thought, this is going to work, right? Not really. So there's a local definition. This is a definition of the word local. Of course, you need a beefy machine. I should have bought maybe a MacBook M3 Max, and then I could have run locally. But for any definition of local, if you have a local machine and a local data network, this morning we talked about the exponential curve of how these machines grow over time. I'm confident that you can run a locally trained model and run it locally and save yourself a lot of money when you do experiments like this. So we've got three things. We have run locally, store locally, and prompt locally. And this will give you lots and lots of benefits on doing your data science in this way. I tried to install Gemini Nano, but I'm still waiting for it to be activated in my browser. And if anybody here has experience with that, please let me know. And finally, I showed this example. Like I said, I showed it to a couple people that inspired me to actually do a startup on this. I showed it also to Carol Willing, who is the co-inventor of Jupyter Notebooks. And she said, like, this is what Jupyter Notebooks should have looked like when we started it. So that was a great compliment I got from her. And it's also my marketing position. So this is not a replacement for Excel. This is not a replacement for Google Sheets. But it's more a replacement for Jupyter Notebooks that allow you to think about your problem not in a linear one-dimensional structure, but more in a two-dimensional, even three-dimensional way of thinking of the dependency graph. This is a very popular way of thinking about this problem at large investment banks like Goldman Sachs and Bank of America and JP Morgan specifically. There's a history of building huge trading platforms based on dependency graphs and getting people off the spreadsheets and have real programming approach to this problem. What I wanted to do is bring these worlds together. So it's more a cultural solution than a technical solution that I was going for. But of course, I spent a lot of hacking time on making it perform well. There's a lot of engineering that doesn't show in this demo. Talk to me afterwards, and I can share you all my nightmares. So with that, thank you for your attention, and come meet me afterwards. I'd like to talk more about Pysheets and also about communication for engineers. If you're an engineer struggling with your career, you want to get promoted, you want to make more money, I will tell you how. So see you there.